Ever wondered how two processes can talk to each other in C? There are several ways to do it, but in this video, we're going to focus on one of the simplest, pipes. Before this video begins, I'm going to assume you have some general knowledge of the C programming language, things like syntax, streams, and function calls. Also, make sure you're comfortable with the fork function. So let's start with the official definition of a pipe. A pipe is a one-way, first in, first out communication channel that can be used between two processes. That means one process can write bytes into the pipe, and whenever the other process decides to read, it will read them in the same order, from earliest to latest. That process then gets to do whatever it wants with that data. This is what makes pipes unidirectional. Data flows in one direction only. For example, if we use fork, we now have two processes, a parent and a child. The parent process writes the message, "Hello child," to the child process. When the child process decides to read it, it will need to specify how many bytes to read. If it wants to read 3 bytes, it will read HEL into its buffer. If it wants to read the whole message, it will read "Hello child" into its buffer. If it has a buffer of size 10 and it wants to fit the message in there, it will only read "Hello CHIL" into it. If you try forcing the child process to read the entire message into a small buffer, you will run into a buffer overflow and end up getting undefined behavior. You will also need to make sure your buffer is properly null terminated because pipes don't automatically put that symbol into the message. If you want the null terminator to be sent to, you must include it yourself. Before even setting up the code, you first need to decide which process will be reading and which one will be writing. They can't both read from and write into the pipe. If you want two-way communication, you'd be looking towards implementing sockets in network programming, or even two-way pipes. Once that's decided, each process should stick to its assigned role when using the pipe. Only one will read and only one will write. What does that mean? If a process is supposed to read from a pipe, it shouldn't be writing to it. Just let the other process do the talking. If a process is supposed to write into a pipe, it shouldn't be reading from it. Just let the other process do the listening. This is to avoid any weird problems. Like for example, you can have a process accidentally send information to itself if it first writes into the pipe, then reads from it. Or you can encounter a deadlock caused by blocking reads, where both processes are waiting to read, but no one's writing into the pipe, so there's nothing to read. But these processes don't know that because they're stuck in the read system function call. And if you're wondering what the kernel does while both processes are blocked, it does absolutely nothing, unless an external event happens, like a signal. And so they just sit there, waiting for someone to write something into the pipe. Once you've decided which processes will be doing the actions, how do you actually communicate? Enter in file descriptors. File descriptors are just indexes that represent open files, streams, or an I/O resource. Notice that I said indexes and not just integers. They live on a table called a file descriptor table, and all processes own one. You know the input and output stream? Yeah, they have their own set of file descriptors called standard in file no, which is just index 0 on the file descriptor table. We also have standard out file no, which is just index 1, and there is also standard error file no. And as you can tell by the name, it serves an important role in providing error messages. Every time a process references these file descriptors in system calls, it's asking the kernel to look up that number on the process's file descriptor and find the underlying resource in it. If the kernel finds an issue, it will spit out an error, typically -1. It's then up to the process to handle that error appropriately. Now, why did I mention file descriptors? Turns out that if you want to communicate with another process using a pipe, you need to make 2 brand new untouched file descriptors and set them to the ends of the pipe. That way, when you fork, both processes inherit access to both ends of the pipe. You can think of these 2 file descriptors as permission slips that both processes have, where file descriptor 0 allows a process to read something from the pipe, and file descriptor 1 allows a process to write something into the pipe. However, you're going to have to take away some of their privileges by calling the close function, just to avoid any of the weird problems I was talking about earlier. Let's see a coding example. We will first create a list of integers of size 2. Then call the pipe function and pass in the list. The list now stores two file descriptors that will be used in the pipe. Call the fork function. At this point, both processes have access to separate copies of file descriptors. This means they both can read and write into the pipe. Now, this is dependent on the OS scheduler. Let's assume that the OS chooses the child process to go first. For this example, let's say we want the parent process to write something to the child process. We will write the code for the child process first. Revoke the child's rights to write something by closing its write file descriptor. Create a buffer named received, which will store the message received from the pipe. Until the parent writes something, the child will be plugged in the read system call. So at this point, the OS would probably switch to the parent. So let's write the code for the parent process. We will revoke the parent's rights to reading from the pipe by closing its read file descriptor. Create a new buffer called message and store the C string by using stir copy. The parent can now write into the pipe. Then close its write file descriptor. This means the parent process is not able to read or write anything into the pipe anymore. Now, let's go back to the child process. Once it's unblocked and has read the message, we can just null terminate it and then print it. And then close its read file descriptor. Now, the child process is unable to read or write anything anymore. Then let both processes return 0. Alright, so some important notes. It's always good to close your file descriptors once you're done using them. They're limited OS resources. The read call we used here will return the number of bytes read. So if it returns 0, that means the process was unable to read anything, indicating that another process has closed its writing end. Make sure to call pipe before calling fork, because if you do it the other way around, you'll end up with two pipes, and I'm pretty sure you don't want that. When you call the write system call, it could block if the pipe is full. It's like trying to stuff more clothes into a full laundry basket. It's impossible. And finally, make sure you error check your code. I didn't do it because 1, the code would have been too long, and 2, I'm lazy.